Good morning to everyone. Myself, B. Krishna, Assistant Professor, Department of Electronics and Communication Engineering, University College of Engineering, Adikavinana University. So here, I am going to discuss about prediction of range performance and minimum detectable signal and receiver noise. In previous lecture videos, discussed introduction to radar system, basic principle of radar system, and maximum ambiguous range, as well as radar range equation. That simple radar range equation there we are derived for the determination of range between the target and radar station, and also discuss the block diagram of radar system in detailed description, and also radar frequencies and radar applications. In this session, I am giving a lecture on prediction of range performance. Already we know the simple form of radar equation or standard form of radar equation in order to find a range of radar. Okay, so here I am going to discuss about these are the major points. So here, see here, this is the simple form of radar equation. It is already derived and express the maximum range, that is R maximum, in terms of radar and target. So this is the simple form of radar equation or standard form of radar equation. So here these are the different parameters. Based on this parameter, we can find the range, the maximum range of this radar in between radar and target. So here this is nothing but transmitted power, and G is the gain of the antenna, and A is the aperture area of the antenna, and here radar cross section of the target. How much amount of area is affected when the radiated signals are reaches to the target, and how much amount of area is affected at the target and then reflected back. Such area is here you can mention with the sigma. So this is the radar cross section of the target. And next one is minimum detectable signal. S minimum is the minimum detectable signal. The minimum detectable signal means how much amount of signals are received at the radar receive station by the receiving antenna. Such signals are nothing but into the space by the transmitting antenna, and those signals are reaches to the target and reflected back to the radar receive station by the receiving antenna. So such reflected signals here we are called as echo signals. So how much amount of signals are received at the radar receive station, and such signals here we are going to represent with the minimum detectable signal. Yes, minimum. Okay, so these are the major parameters here, and here now we are going to discuss about on this particular radar range equation is able to find out the range in between target and radar station. If it is possible or not, if it is not possible or it is not able to exert calculation, what happens? Why it is not calculated exert response or exert function in between target and radar? So here, suppose if the longer ranges are to be determined, suppose if the longer ranges to be determined, then some of the parameters in that equation are extended. And expect for the target cross section sigma and S minimum. Such problems are nothing but one of these problem, peak power transmitted by the radar. that is transmitted power should be high. Okay, here we require the transmitted power should be high because of for the longer ranges. If the target is available in longer ranges, then the transmitted power needed is very high. Then only we can transmit the signal into the space, and such signals are reaches to the target and reflected back to the radar receive station. And similarly, another point is gain of the transmitting antenna is high. So the gain is also very important here to increase it if the longer targets are present in the space. And next one is radar cross section should be high. Next, effective aperture area of the receiving antenna AE should be high. Next, power of S minimum should be low here. Why? Because here the longest ranges is required. Longest ranges are present in between radar and station. The signal is also having low power. Okay. So whenever these signals are satisfying, whenever these signals are going to, then only we have to find the maximum range. But here, the radar cross-section target, that is cross-section of the target, nothing but sigma and minimum detectable signal, such as reflected signals, are unpredictable values. Because of these are statistical values, and so we can't predict the exact value of the target cross section as well as S minimum in this problem. Okay, so hence, in order to cover these aspects, in order to cover these aspects, the simple radar equation will be modified to include most of the important factors that influences the radar range performance. Okay, so these are the major parameters here affected. These are the major parameters here affected when the target is present in longest range. In that case, these are all required very much high. Then only we can find out the accurate result of this particular regarding target is present in the space or not. And such targets are when we are radiating the electromagnetic signal into the space. Those signals are reaches to the target and reflected back to the radar receive station to analyze the signals. Based on the analysis of the signal, we can identify the target is present in the space or not. If the target is present in the space, and then we can find the range between the target and radar station, and also in which direction it is available, and also how much height above the earth. That will be also calculated based on this radar system. Next topic is here minimum detectable signal. So minimum means the meaning is in this minimum number of detectable minimum number of signals are detected. So such signals are nothing but echo signals. So here let us discuss about this minimum detectable signal. So the weakest signal here, the weakest signal that can be detected by the receiver is called minimum detectable signal. Okay. In there, the first point is if the radar cannot detect echo signal, the first point, if the radar cannot detect echo signal, if that signal is having less power than that of minimum power. Why the radar cannot detect echo signal? If that signal having less power, this is the one of the problem is in previous previous method, previous topic. So when the power is less, it may not be detectable because of that signal having weak power, weak strength, weak signal. Then that type of signals are not detected by the radar receiving antenna. So to increase the signal strength, then only to increase the signal strength, then only the echo signals are detected at the radar receive station. How the signal strength increases? Because of you have to increase the transmitted power transmitted power, then only the signal's strength or increases. Then only such signals are received at the radar receiver station after reflecting from the target, and that signals are detected with the radar receiver antenna and sent to the radar station. Now process the signal, and to analyze the signal based on that result, we can identify the target is present in the space. Okay. So next. So here, next point is based on the specification, the minimum detectable signal is difficult. Based on this specification, the minimum detectable signal is difficult because the statistical nature, whether a target is present or not. Okay, and here the weakest signal is that can be detected by the receiver is called minimum detectable signal. Okay, let's see here. Let's see here. Figure the typical envelope of tile radar receiver output as a function of time A and B and C represent signal plus noise. A and B are would be valid detection, and but C is a mixed detection. Why A and B are the valid detection but C is a mixed detection? So what is the function behind this? Now we have to go through this particular diagram. So let us observe this diagram. On y-axis, we are taking voltage, and x-axis here we are taking time. Then you have to observe the some establishment, such as one is threshold level and second one is RMS value of the noise. And one more thing here, it is a signal. This signal is nothing but reflected signal received back to the radar receiver station from the target. So here, let us observe the signal. The signal is going in like this different levels. So in this here we are making 3 points, such as one is A and second one is B and third one is C here. Okay. So here the signals levels are going like this, and here the signal is going like this, and here the signal is going like this, like this, like this, like this, and like this. Why this signal is here and why this signal is here? Nothing but so here the signal is coming to the radar resolution is strongest strength. Then only such type of signals are okay. Such type of signals are cross over this or exceeding this level. Then only we can identify the target is present in the space. Okay. And the second point here, the signal strength is equal to the threshold level. Here also, again, the target is present in the space. It is also valid indicator. And coming to the C, here the C is nearly close to the threshold level, but not equal to the threshold level. Some gap is there because the signal level is weak signal strength, so it does not cross over this level. So then this is the mixed detection. Why we are saying it is a mixed detection? Here the target is, this is also strongest signal. This is also one of the strongest signal. The target is available, but it does not cross over the our established threshold level. Means we can estimate the target is not present, but there is a target. Why we are not estimating the target as present? Because of it does not cross over the level, but there is a target. So means the point C is missed detection. Missing. The target is missing in the space. Why? Because the signals are not, does not cross over the level. So we can simply say the target is there is no target, but there is a target. This we can say it is a missed detection. Okay. Let us discuss those points. First point here, we have to consider the 3 points. Okay, as we seen in previous slide, here point A, point B, and point C. In the above figure, for identifying the valid detection and misdetection. Valid detection and misdetection. A and B are the valid detection and C is the misdetection. Next point. The value of the signal at point A is greater than the threshold value. Greater than the threshold value. Means what happened here? Hence, it is a valid detection. As I told you in previous slide, the point A, the signal level will cross over the threshold level. So the target is present. We can identify the target is present in the space. So it is a valid detection. Valid detection. Next point. Even though the value of the signal at point C is closer to the threshold level, but it is missed detection. It is a missed detection. Missed detection. Missed detection. Because the value of the signal is below the level only. The target is there, but the signal is not crossed over the level. The target is present, but here simply here we can say it is a misdetection because of the value of the signal is below the level. So the point A, B are valid detection, whereas point C is misdetection. So next, the detection of radar signal is based on establishing the threshold level at the output of the receiver. Okay, let's come to the this one at the diagram. What you can say here? So the detection of a radar signal is based on establishing a threshold level at the output of the receiver. Okay. Suppose here you can establish threshold level below some points here like this here in this area. Then what happen? This signal is also crossover. 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 And this signal is also crossover the threshold level. Because but these signals are all are what this is here noise signals. Some level is available, but maximum these are the noise signals. When such a noise signals are crossover, if you are establishing a level here, crossover this level, then what we have identifying here? Simply there is no targets present in the space. If you identify at this level is target is present, at this level is target is present, at this level target is present, at this level target is present, but there is no target in the space. So then we can say it is a false detection. False detection. Why? Because the noise is maximum in the received signal, that is received station. So obviously we can change the threshold level some points above. Okay, right. Next, if the receiver output exceeds the threshold, the target is assumed to be present. Okay, if the threshold level is if the threshold level is set too high, then what happens? There is some weak signals are also reflected from the target and received to the radar station. Such signals are not crossover, are not exceed, or may not be exceeding the threshold level. All are the comes under the missed detection. Why? Because it may not be exceeding the threshold level and the target is not detected simply. But there is a target. We can call it as missed detection. Suppose if the threshold levels were too low, then what happened? As I told you now, just now I discussed that. If the threshold level were too low, then the noise might exceeds. The noise might exceeds it. It will be mistaken for target present. What we say there? False detection. Nothing but false alarm. We call it as false alarm. So to set the proper threshold level such that to eliminate the false detection and mixed detection properly. Okay, you can set the proper level, proper threshold level. Then only we can find the target is present in the space is accurately based on the reflected signal, such as echo signals at the receive station by the receiving antenna. Okay, so this is the minimum detectable signal concept. So next here, receiver noise. You know about the noise. Noise means some unwanted signal. These unwanted signals are occurred at the are received at the receiver. So then what we can do? Then what happen? What we are discussing previous slide, such type of problems are occur. So what we can do it here? So is there the noise is present along with the signal or it is generated at any points or any junction that we can discuss in here. The noise are enter along with the signal from the target through this medium or is there any noise or generated itself at this equipment? We can discuss here. Okay. First, the noise is a unwanted electromagnetic energy which interferes with the ability of the receiver to detect unwanted signal. Ability of receiver, okay, to detect unwanted signal. Next, it may originate within the receiver itself also. ఇంకేమంటున్నాడు రిసీవర్ దగ్గర కూడా అది జనరేట్ అయిపోవచ్చు అక్కడ తీసుకున్న ఎక్విప్మెంట్ లో కూడా అది ఆటోమేటిక్ గా నాయిస్ అది జనరేట్ అవ్వచ్చు అన్నాడు ఆర్ ఇట్ మే ఎంటర్ వయా ది రిసీవింగ్ యాంటీనా ఆల్సో యాంటీనా ద్వారా కూడా కొంచెం నాయిస్ అది ఎంటర్ అవ్వచ్చు అంటాడు అలాంగ్ విత్ ది డిజైర్డ్ సిగ్నల్ సో ద అవైలబుల్ థర్మల్ నాయిస్ ఈస్ KTBN which is generated in the receiver part. So where Bn is the receiver bandwidth and T is the temperature in Kelvin and K is the Boltzmann constant. So based on that, the noise figure is represented as that is noise out of practical receiver by noise out of ideal receiver at standard temperature T naught. That is equal to noise out of practical receiver by K T naught GA and Bn. So that noise figure also represented as that noise figure is also represented as Fn equal to Si Ni by that ratio by input signal to noise ratio by output signal to noise ratio is nothing but noise figure. So from the above equation we can find out the Si input signal then it is Si equal to K Bn T naught Fn S naught by N naught. If the minimum detectable signal, if the minimum detectable signal S minimum is that the value of Si corresponding to the signal to noise ratio S naught by N naught necessary for detection, then S minimum equals K Bn T naught Fn ratio of S naught by Sn is the minimum. Okay, so here instead of Si we can replace with the S naught by N naught. Substitute this value here in the above equation. Substitute in the above S minimum value in radar equation, then we can get R power 4 maximum equal to PT G A sigma by 4 pi whole square K Bn naught T naught Fn output signal to noise ratio is minimum. So this is the modified equation for signal to noise ratio. So based on this, we can find out the accurate values, the accurate performance for the between radar and target. So this is a overview of the prediction of radar range performance and minimum detectable signal and receiver noise. Okay, thank you.